Hi everyone. I'm going to give you a short tutorial on running a binomial distribution and creating a table in Excel. It's a fairly simple process. You really only need one formula for this, and that's the binom dist formula. And I'll show you how to make that work. I'll show you how we can quickly create a table and then also define probabilities as a result, whether we're looking for the probability of one R value or one situation, or whether we're looking for things such as at least a certain number or at most a certain number or less than or more than a number. I'll show you that also very quickly, how we can make that happen in Excel. You'll get a little bit further instruction in class on that with some examples, but this should give you a basic idea of how you can set up your own table and make that happen rather quickly. So with that being said, let's get started. The situation I had with it coming closer, getting close to baseball season, I have a situation in which we have a player. You pick your favorite professional player, and let's say his career lifetime batting average is 310, meaning that 31% of the time we can expect that player to get a hit when he comes to bat. Uh, well, what if we looked at 10 at bats in a row? And there's situations in which you hear about players getting hits in so many at bats in a row, and it's kind of an improbable thing. And it goes back to basic ideas of probability. You can either get a hit or you don't get a hit. Walks don't count as at bats, so that's a little bit different. But in this case, just to set this up, we have a number of trials. And remember, each at bat is virtually, for the most part, independent from the others. So I'm just going to look at, okay, what are my n values here? And that's, 1, or I could start with 0. What's the probability to get 0 hits? 1, 2, 3, 4, 5, all the way to 10. 10 meaning the most hits he could get in 10 at bats in a row. And then we'll look at the probability. Okay, well, how do we make that happen? It's a simple formula, and I'm just going to write it. I'll make a note of it here, and you'll see it pop up in the function bar. You could do a search, so I'm going to do that first. And other times you could just type in an equals. Notice that the function bar does that for you. We're looking for, and you might need to type this in, but I'm looking for the binom dist. I've used it recently, so it's there for me. So you're looking for binom.dist for binomial distribution. And if you look at the description, returns the individual term, the probability for binomial distribution. Okay, I'm going to choose that. Now here's the quote-unquote tricky part. We need to enter the S, which the S is the number of successes in trials. Well, if we think about the idea of getting a hit as being the success, in this first example, the probability or the number of successes is 0. So that's going to be a 0. So what's the probability in 10 at bats, based on the fact he's a 310 lifetime hitter, that he won't get a hit? There are times in which hitters go into slumps. What's the likelihood of that happening? We can kind of look at that and say, that probably shouldn't happen. Trials is a number of independent trials, which would be 10. That's our n value. Okay, trials is n. The probability of S, the probability of success, in this case is going to be 0.131. Okay. And our cumulative, this is always going to be the same, and this might seem a little strange, but you're always just going to type in the word false here. Okay. By typing in the word false, it's going to give you the probability for just that one situation. The probability that he gets 0 hits, and it shows you here, and I'm just going to go ahead and click OK, is 0.024462, which, again, we can change that. We'll move that decimal here in a second, but that's basically, there's a 2% chance in 10 at bats that he won't get it. He won't get a hit at all. Now, I'm going to do this very quickly. I'm going to go ahead and copy and drag. I'm going to click and drag it. Notice it's repeating the same number over and over and over again. But what I'm going to do for each of these other situations, and this is how the quick and dirty of it, instead of continually typing in binom dist, I'm just going to go into each of these functions, and the only thing I need to change is the first number. That's the R number, the number of successes, or the S. So the probability of him getting 1 hit in 10 at bats. The probability of him getting 2 hits. So on and so forth. So if you're following along with this problem, at this point, pause the video, go back, work your way through this. That's what I would suggest you do, is to set up this situation and do it on your own and compare it back to what I'm going to have here at the end. So I'm going to quickly go through that. Like I said, pause the video, work your way through. Let's see if our numbers match up. And if we know anything about probability and we think about discrete distributions, the sum of all these probabilities when we add them all together at the end, notice how small of a number this is. It's giving us an E value, which is scientific notation. If I do a sum here, you could probably tell me what the sum's going to be. Anybody want to have a guess? That's right. It's going to give you a sum of 1. At least it better. Okay? So Excel does a very nice job of that for you. Now, in terms of making these numbers so we can really understand them, typically we'll go to the nearest thousandth place. So I'm going to take us down to 3 decimals. Again, I'm just going to use this little number area up here, move this thing over. And there's our probability. Okay. Notice that based on the idea that he's a 300 hitter, if you think about how many times out of 10 should we expect him to get at bats, n times p is, p times 10 would be 3.1. So if you notice, the highest probabilities center around 3 hits. 2, 3, 4 hits, notice the probabilities, and then from there kind of fall off. That's typical. Okay, so we get kind of we want to think about a histogram or kind of a bar graph of what these proportions look like. It would give us kind of a normal looking curve, or give us kind of that bell-shaped curve there in the middle, okay, around that expected value. Now, we got this. Good to go. The other things we can look at is to say, okay, well, what's the probability of, let's say, getting 3 hits? Okay, well, that's pretty easy, right? The probability of him getting 3 hits was 0.266. Or we could say about 27%. He's got about a 27% chance of getting 3 hits and 10 straight at bats. Okay. Would be the probability of him getting 10 hits in a row. Okay, based on the fact he's a 300 hitter, well, if you look, basically say it's virtually probably going to be impossible. So you can say basically 0% or it's improbable. Does that mean it can't happen? No, sure, it can happen, but we just don't expect it to. Now, the big ones are, what's the probability of getting, let's say, at least 4 hits out of 10? Well, what can we do there? Well, here's a quick and easy way of making Excel work for you. We want at least 4. So if we're talking about at least 4, we're saying 4 hits or more. So what I'm going to do is I'm just going to select that 4, and I'm going to select the probabilities below it. And if you look down here below that, down in the toolbar at the bottom, I get a sum of 0.377. There's my answer. If you have a calculator, you can add them together. Again, I kind of find that would be a waste of time. What if we said, what's the probability of him getting at most 4 hits? Well, what are we looking at then? Well, at most, 4 would be the most he could get. 0 through 4 would count for that. This goes back to a review of inequalities, and if you kind of struggle with that, you've got to go back and look that over. But if you look at my sum now, he's got about an 83% chance of getting at most hits. So, quick, easy way, quick and dirty way of doing a binomial probability distribution. We're going to use this. We're going to avoid using the textbook. We're going to avoid using the formula. This is what you're going to rely on for binomial probability distributions. So I hope this was helpful. Again, try it. Choose an n number, choose a p-value, plug it in and see what happens. And if you want to share it with me, I'll take a look at it with you and make sure you know what you're doing. All right? Thanks, gang. Good luck.